Hello friends, thanks for joining me. My name is Anand Mangipudi and I'm a BI and data warehousing consultant based in Nottingham, United Kingdom. I blog at anandmangipudi.com, so please do check out my blog for other BI related resources. This is the first of the several videos I intend to share about BIML and its use cases, especially for SSIS packages. I hope you enjoy this series as much as I do. So without any further delay, let's start the first session. BIML is the Business Intelligence Markup Language. It has BI domain-specific XML dialect, so we are not exactly entering into an unknown territory here. BIML script is BIML plus C# or VB code nuggets through which we achieve automation. With BIML, we can standardize our naming conventions, say for our SSIS packages, tasks, and transformations. We can have predefined templates and patterns which can be used to generate multiple packages, all having the same structure and standards. This aspect of code reusability is very effective for maintainability and change management purposes. One of the common scenarios in data warehouse is populating the staging environment, where staging is a replica of the source, especially in ELT type data loads, where we extract, load the data into staging, and then do transformation. The intention here is to minimize the disruption to the source system and do the heavy data transformations between the staging and the data warehouse layer. As we can see in the slide here, the commonly used pattern for staging loads is the truncate and load pattern. In this case, we have three packages for three-dimension tables: products, stores, and customers, each actually doing the same operation. We have a control flow task where we truncate the staging table, and then in the data flow task we read from the source and then populate the staging table. Such patterns can be effectively automated with BIML and BIML script with very minimal code. So the goal of this session is to achieve this package development using BIML. Sounds interesting, right? You might think it's easy to drag and drop rather than learning a new language. However, believe me, when you have dozens of tables which you need to replicate, drag and drop isn't the most productive option. And especially if you are a consultant, automating this whole process using BIML gives you a perfect reason to show off in your stand-up meetings. Alright, it's time for some action. First, we create an SSIS package to load a sample products table from source to staging via a more conventional manner, the drag and drop option, and then we'll do the same, but now with BIML. So let's jump to the demo. So this is my Visual Studio 2015 Community Edition. And I've created a new SSIS package, load products. I already set up two connection managers, one pointing to the source AdventureWorks 2017 and the other to the staging table. So this is my AdventureWorks source production.product table. For the purpose of this demo, I'm only interested in ID, name, the number, and the color, and this is the staging product. We'll just truncate the table so that we'll load through the package. Yeah, that looks fine. So for the truncate and load, we'll just drag and execute SQL task to truncate the table. Just as truncate staging product. Just use the staging connection and have a truncate table product, and then I'll have a data flow task to reload the table. It's always recommended to follow a consistent naming convention. So for a data flow task, I've just abbreviated as DFT, and load staging product, and have the names as verbose as possible. So in cases of failure, it's easy to troubleshoot the specific transformation or the task. So we'll have an OLEDB source to read from the production, from the AdventureWorks production.product table, and instead of a table, we'll choose the SQL command, as it is recommended to choose the columns which we need rather than choosing the table, because in that case we'll issue a select star and that will have performance implications. So the mappings look alright, and then we'll have an OLEDB destination to load our staging product table. So this is a simple truncate and load setup, and just have select the staging as our destination, and select the product table, and the mappings look okay, and then we could execute the package, and yeah, it looks all right. We'll just see if we have the data loaded. Yeah, so we have the data loaded from the source to the staging. So now we'll recreate the same package using BIML. I have already installed BIML Express add-in to my Visual Studio. We can add a new BIML file from either here or by right-clicking our project and adding a new BIML file. So this creates a new BIML script.biml file, and as we can see here, BIML has an XML dialect with a namespace, XML namespace pointing to an XML schema definition file for BIML. Here we can also see a preview pane. This is especially useful when we are dealing with BIML script. So for now, we'll just hide the preview, and I'll just create a vertical tab so that it's easy for us to replicate our SSIS package here. So in order to add the package, first we need to add the packages collection element, and then we could add the package. So IntelliSense in BIML Express is pretty handy, as we can see, it shows all the available attributes for the package element. To start with, we first give the package a name, load products BIML, and we can close close the element with a closing tag. So at this point, if we could generate a blank SSIS package by right-clicking the BIML file and generating SSIS package. So as we can see, we created a blank BIML .dtsx package. So the next step would be to add the connection managers. As we can see here, we have two package level connection managers in the package. So from 2012, we could add project level connection managers, which could be accessed among all the packages in the project. So that would be a preferred way of creating your connection managers, as we don't need to create connection managers for each package. So to add a connection manager, we first need to add the connections collection, which holds all the connection managers, and as we can see, we can add an Excel, flat file, HTTP, OLEDB connection. So that we'll select an OLEDB connection and we'll give it a name, connection source, and the connection string attribute. So we could copy the connection string from here, and we could by adding the closing tag for the OLEDB connection. So we could add the second connection for the staging target in a similar fashion by providing the connection name and the connection string in the same fashion. And then we close with a closing tag. So this creates two connection managers for the source and the target. So next we will add the control flow task to truncate our staging table. So as we can see, for the execute SQL task, we have a connection to the target staging table and a source type as direct input and a SQL statement to truncate our table. So in order to replicate the same using BIML, we first add the task collection, which has all the control flow task elements, and then we select the execute SQL task. We give it a name as truncate staging product and a connection name to the connection which we have already set up, the connection target, and then we add the direct input to include the SQL statement to truncate our table, truncate table product. So this creates the control flow task to truncate our staging table. The next step would be to create a data flow task to load our staging table again. So we could add the data flow task and give the data flow a name. In this instance, we'll just use the same name, and then we close our data flow with the closing. So now if we could save our BIML file and can check for errors. So it's always recommended to check for errors and then deploy incrementally, just to make sure we are in the right path. So as we can see, there are no errors or warnings found. So now we could generate our SSIS package. So it would ask to confirm our changes and commit to overwrite our existing BIML package. So once it's completed, we can open our BIML package, and as we can see here, it has created the two control flow tasks, the execute SQL to truncate our staging product table and a data flow task. But we see an issue here, as we don't have any precedence set up between these two tasks. So these would execute parallelly, and we would want to execute them in a serial fashion to first truncate our table and then perform the data flow operation. So now we need to set up a precedence constraint so that we have the data flow after the execute SQL task. So we will close. We will not save any changes to the BIML package, but then we would change our BIML script to add our precedence constraint for the data flow to execute after the control flow task, after the execute SQL task. So we could add the precedence constraints by by including the precedence constraint element, and we have an input collection with an input element, and this shows up all the attributes. In this case we would select the output path name. So here we would want the output of the execute SQL task as the input of the data flow task. So now if we save our BIML script file and regenerate our SSIS package after checking for any errors, we should see the precedence constraint set up between our two tasks. So we'll generate our SSIS package, we'll commit the changes to overwrite our existing version, and now we could see like the precedence constraint set up between the two tasks. So once our execute SQL task completes or is success, then the data flow task would execute. So we'll close the package, and now we can add the transformations in the data flow to read from the OLEDB source and load it to our destination. So first we will add the transformations collection, and then we would add an OLEDB source element. Similar to the execute SQL task, we first give the OLEDB source a name to read from the production product table. So we could reuse the same name, and we'll use the connection we have created already, the connection to the source to read from the OLEDB source, and a direct input element to read, to have the SQL command to read from the source table. So we could just copy the SQL command. So in this case we will not need the database reference, as we already have it in the initial catalog and the connection string. Right, so we have the OLEDB source to read the data from the source, and then we could add the OLEDB destination to load the data. So we'll close it with the closing tag, and we'll first give OLEDB destination the proper name, and then the connection will set up to the target as we already have in our BIML collections, and then we'll add the table name, the XML table output, the product table to load the data into the table, the product table, and then we'll close it with the closing tag. So this should replicate our truncate and load pattern to first execute to truncate our staging table using an execute SQL task, and then load the table from the source in the data flow. So we could save our BIML file, and we'll first check BIML for errors just to be sure. and once it completes the checking, we could generate our SSIS package. So we will confirm our changes, and you can see it's completed. So as we can see here, so now we have an execute SQL task, truncates our staging table, and then we have a data flow task which reads data from the source. So it has automatically created all the mappings from the source to the target, and then it loads the data to our target product table with all the mappings automatically created. So now we'll just make sure the package is working fine. So we don't have any data in our staging table at the moment. So we will run our newly created package with BIML. So we'll execute our package. So as we could see from the output, the execution has failed because the package protection level is different to that of the project. So if we go to the properties of the package, we can see like the protection level is set to don't serve sensitive, whereas if we go to the project properties, it is encrypt sensitive with user key. So we need to make sure like both the package and the project level properties for the protection level are the same. So we would close the package for now, and in our BIML file for the package element, we could set up the protection level to encrypt sensitive with user key to make sure both of them matches, and we'll save the BIML file, and we generate the package again, and hopefully this time it succeeds. So that's one point to remember. So we'll commit our changes, and we will execute the package again. So now it looks like, yep, it succeeded. So we will go to our management studio to just verify. So as we can see, we have the data loaded into the staging table. So we could truncate it again, just to rerun and make sure like we have the package running as expected. So we execute the package again, and as we can see, it has completed successfully, and we have the data loaded into the staging table. So now we have replicated our SSIS package creation using the BIML script. So as we can see from the first demo, it is pretty straightforward to replicate the package creation using BIML, and in the next series of videos we would see more of BIML to automate our SSIS package developments, and also we will introduce BIML script using which we would take our BIML journey into the next level. So these are some of the useful links to the Verigen's website to download the BIML Express latest version, and as well as to Andy Leonard's blog I have been following Andy Leonard from a long time, and he has been an inspiration to me for all the SSIS design patterns. So I would recommend everyone to have a look into his blog. And also I have included the URL for Visual Studio downloads and the SQL Server Management Studio. Hope you found this session useful and learned something new. Please leave your feedback in the comment section below and subscribe to my channel, which would encourage me even more to create and share new content. So thanks again. See you in the next video. Bye.